Okay. Again, my name is Michael Levis, and I'm going to be discussing classification of thermal images, specifically of power lines, utility poles, and their equipment. Thermal imaging can detect hotspots on electrical systems prior to their failure. And so I was provided over 2,250 thermal images of utility equipment by Precision Hawk, and they specialize in acquiring images, thermal images with drones. And so the objective is we want to define the best supervised machine learning and predictive models to identify bad images while minimizing false negatives. We don't want to throw out a lot of good images with those. And by bad images, I'm talking about blacked out, saturated, or blurry. And identifying the bad images prior to processing may provide significant cost savings. And in order to measure the accuracy and to demonstrate the accuracy, basically our primary goals, we're going to use a confusion matrix showing the predicted images versus the true images, the true labeled images. The primary goals are going to be to get the good and the blacked out images identified, with the saturated and the blurry as secondary goals. So we'll start with a good image and its histogram. And you can see there's a hot spot on one of the connectors. But mixed in with those are some blacked out images. These are fairly easy to identify. The histogram skewed to the left with the values highly concentrated. Saturated with the image with the histogram, skewed to the right a little bit. And then a blurry image with its histogram, a little bit tougher to differentiate from the good images. But hypothetically, if you're paying 5 cents an image for these bad ones, a contract of, let's say, 100,000 utility poles at 10 images per pole, even if 20% of those are bad, you could, and you can identify those bad images. You could save up to $10,000 on just a small contract like that, just hypothetically speaking. So I checked out different supervised machine learning models, logistic regression, there's a SVM and gradient boosting and random forest. For more information on these, you can visit my GitHub page. I have all the different models tested there, but I did find that the random forest method is the best model. And looking at the confusion matrix, you can see a high percentage, 95% the good ones were identified. 100% of the blacked out were identified, and we still identified 2/3 of the saturated and a little over 10% of the blurry, so that was good. So the final product is going to be a program. It's a program that accepts a folder of unlabeled images and produces a table with the labels of each image. Here's an example when you run it through the program. For more information, my information, michael.levis@colorado.edu. Here's my GitHub page for more information and the code on all the different models that I tried. And I'd like to thank Blaine Horner with Precision Hawk, also Jake